All right, so we're going to work our way through these 3 steps in cellular respiration, starting with glycolysis, the first step in the process. And as we go, we're going to kind of remind ourselves or orient ourselves where in the cell it is happening, the reactants that go into each part of the reaction, the products that come out, whether or not ATP is used or created, and are any waste products produced in each step of the reaction. All right, so glycolysis is the first stage of cellular respiration, and it occurs in the cytoplasm of the cell, so kind of out in this jelly area out here. Remember, mitochondria you're probably most familiar with as being the powerhouse of the cell. It is the site of the last 2 steps of cellular respiration, but glycolysis does not happen in the mitochondria. Glycolysis happens outside the mitochondria. Glycolysis is what we call an anaerobic process, so it does not require any oxygen. Later in the other steps, you'll hear about aerobic processes requiring oxygen, but glycolysis is not one of those. And in glycolysis, we're taking that sugar, the organic macromolecule glucose, and we are splitting it up, not all the way down into CO2 just yet. We're kind of doing an intermediate breakdown before that production of carbon dioxide in the second step of the process. And so in glycolysis, all we're doing is taking glucose, a 6-carbon sugar, and cutting it in half and creating pyruvate, a 3-carbon sugar. In this process, we create 2 molecules of ATP. So we do trap a little bit of energy in ATP in glycolysis, not a whole lot. And we also create 2 molecules of NADH. NADH is what we call an energy carrier. And so it's holding on to energy in its bonds. It's holding on to some extra electrons that later on in cellular respiration is going to donate to power the final process. All right, so if we want to summarize kind of what glycolysis looks like in terms of what goes in and what comes out, I like to boil it down into glucose, sugar going in, ADP going in so that we can create ATP. You can't add a phosphate group to nothing to make ATP. You've got to have ADP there to start with. And then NAD+, again, the energy carrier in its in its oxidized form, ready to be reduced, ready to gain electrons. Okay, and over the course of this reaction, over the course of glycolysis happening in the cytoplasm, we are breaking that sugar in half, literally just taking that 6-carbon sugar and creating 2 3-carbon sugars, glucose to pyruvate. We're phosphorylating ADP, adding a single phosphate group to ADP to create ATP, and we are adding an electron to NAD+, or remember in biology you can just track hydrogens instead, adding a hydrogen to NAD+ to create NADH. And now in this NADH molecule, we created an extra bond, and in that bond, we're holding on to energy to move into a later stage. So if we come back to our table here, in glycolysis, we're out in the cytosol. Glucose goes in. So we've only so far accounted for one of the main reactants in our overall cellular respiration reaction here. ADP and NAD+ go in, and then pyruvate, ATP, and NADH come out. And we aren't just doing this in a single step, you're going to see in the next slide. We are overall creating 2 molecules of ATP in this process, but we're overall using 2 molecules in the process and creating 4, so we get a net output of 2 ATP overall. It's a multi-step, about a 10 reaction process just to break glucose down into pyruvate, just to go from this 6-carbon sugar into this 2 3-carbon molecules here. And we don't create any waste in this reaction. This image comes from your textbook here, and so just as a reminder, this is your mitochondria, or mitochondrion is the singular form of that organelle, and out here in the cytosol. So you can imagine that the membrane is around the outside of this image somewhere. And like I said, it's a 10-step process. I would never expect you to memorize any of these steps in here, but this kind of overall layout should look familiar to you from Unit 3. So when you think about metabolism and enzyme-mediated metabolism, each of these transformation steps is facilitated by an enzyme. And so hexokinase is an enzyme whose substrate is glucose. And when hexokinase and glucose come together, they produce the product glucose 6-phosphate. And in the process, they require a little bit of energy to do that. So here's one of the ATP molecules that's actually used in this process rather than created. And then again, further down the line, we use a little bit more ATP, the second one that gets used. So we call this top half the energy investment phase. And then energy payoff phase down here, over the course of these transformations with the use of various enzymes, we are eventually creating NADH, that energy carrier, reducing it to hold on to extra energy. We're creating some extra ATP out here and creating some extra ATP out here. And in the last step of this reaction, we produce pyruvate. And these pyruvate molecules are ready to then travel into the second reaction of cellular respiration, which is the Krebs cycle or citrus acid cycle. And so I'll meet you in the next video to talk about that.